Welcome to Chemistry with Dr. Z. I'm Dr. Z, and in this video, I'm going to talk about the states of matter and the physical changes that leads to change between one state and the other. So we know that there are three states of matter: solid, liquid, and gas. Any material can exist in any of these states of matter, and the state of any material at certain temperature will depend on how strong the forces of attraction between the particle at this particular temperature. So, how strong the forces will depend on three factors. The first one is the material itself. And when we say the material itself, we mean the structure and the type of intermolecular forces. And these are the forces, the intermolecular forces are the forces which hold the particles together. So if we remember that ionic compounds have very strong intermolecular forces, metallic compounds have very strong intermolecular forces, while covalent compounds have weak intermolecular forces. So the type of the intermolecular forces, the type of the material itself will affect or affect the state of the matter, its state at a particular temperature. The second factor that affect the state of matter is the temperature itself, because even with a material like the ionic compounds and metallic compounds, which have very high melting point or very high strong forces of attraction between the particle, they still can change their state depending on the temperature. The third factor is the pressure. So when we talk about the different states of matter and try to explain how they look like and their behavior, we need to look at what is called the particle theory. So particle theory is a model that explain how the particles in a material behave in all different states of matter by considering that each particle are small, solid, and in elastic spheres. These are some of the limitation of that model, but we are going to talk about the limitation at the end. So let's use the particle theory to try to explain the behavior of the particles in all the three states. Let's start off by talking about solids. So solids, there are strong forces of attraction between the particles. So the particles are held closer together in fixed position to form regular lattice arrangement. As we can see in the figure here, this is a representation of a solid where the particles are arranged in um, close proximity to each other. They are regularly arranged and they are fixed. They have fixed position. Particles, as we can see, they don't move from their position because of the strong forces of attraction between the particles, so they cannot escape that strong force of attraction. This is why solids have a definite shape and volume, and they do not flow. The particles, however, can only vibrate about their position. And the hotter the solid gets, the more the particles can vibrate. So they vibrate a bit faster and they might expand if they get hotter. They will stay as solids as long as the temperature is below the melting point. So moving on to do the same for the liquids, try to explain the behavior of the particles using the particle theory. So for liquids, there are weak forces of attraction between the particles. The particles are now randomly arranged but they still stick together. So as we can see here in this diagram, the particles are randomly arranged. They can move past each other, but they still stick together. As you can see, they still stick together. They have, because they still stick together, they will have definite volume, but they don't keep definite shape because they can move freely past each other. And this is why they would either fill the bottom of a container or take the shape of the container. The particles are constantly moving with random motion, but again, the hotter they get, the higher the temperature, they will move faster. They will stay in this state as liquid as long as the temperature is below the boiling point. Moving on to talk about gases. Gases now have very weak forces of attraction between the particles. The particles are completely free to move and they are far apart. So when you draw the particles of gases, you must keep them far apart. You don't put them close together or they don't stick together. They don't have definite volume or definite shape. They will fill any container. The particles are constantly moving with random motion. The hotter they get, the faster the particles will move. So they are either expand or the pressure will increase when heated. So this is the gases. Now let's more talk about the limitation of the particle theory. So we said that the particle theory considered all the particles as spheres, as inelastic and solids. But in fact, not all particles are solid spheres and elastic. Particles are actually categorized as ions or atoms or molecules, and they do have different shapes. They are not all spheres. The second thing is that this model doesn't actually consider the type of forces between the different particles of any matter. So we know that the intermolecular forces or the forces between the particles differ depending on the type of the particle. So the ions have different type of forces than the than covalent compound, which is completely different than the um, um, the metallic when we have metallic bonding or metallic compounds. So the particle theory doesn't take that into account, but the explanation itself is enough to generally explain the behavior of the particle at the different states. So let's summarize the different states of matter and the difference between them. So when we look at the diagram of the three, the solids will have this regular arrangement where all the particles are arranged regularly. They stick together and they keep themselves in place. For liquids, there will be a random arrangement, but they will still stick together, as we can see for the liquids. For gases, they are so far apart, randomly arranged. There is no closeness between the particles. They are completely far apart. When we compare the particle movements, the solids only vibrate about fixed position, as we can see here. For the liquids, they can move around each other or past each other. For the gases, they move quickly in all directions, so they are move freely in all directions. The closeness of the particle, as we can see, solids very close, liquids are still close and they stick together. This is why they have definite volume. And then for gases, they are far apart from each other. This is why they don't have definite volume. Now let's talk about the physical changes between the three states of matter, solid, liquids, and gases. We know that any matter can change its state between solid, liquid, and gas, usually when it gains energy. So let's explain that using the particle theory. So when solids change into liquid, this is called melting. And what happened is that when solid is heated, particle will start to gain energy. So it's all about gaining energy. So when particles gain energy, they start to vibrate faster and the forces between the particles will weaken. At melting point, the particle will have enough energy to break free from their position. So once they are able to break free from their position, they will change their state from being solid into being liquid, and this is called melting. Now let's talk about the change from liquid into gas and also use the particle theory. So we're going to apply the same principle, the same model. So when a liquid is heated, the particle again will gain more energy. So particles now don't vibrate, but they move, so they will start to move faster. As they move faster, the forces of attraction between the particle will weaken, and the bond that hold the particle together and make them stick together will will break. So at boiling points, this is boiling, so at boiling points, the particle will have enough energy to break their intermolecular forces completely, and they start boiling, and the liquid becomes a gas. Now let's move on to the other side where the gas changes into liquid. This is a process called condensation. So now the particles will lose energy. So we're going to cool them down and they start to lose energy. So for gases, when gases cools, the particles will lose energy now and they will start to move slower. As they move slower, the forces of attraction between the particle will be regained. Again, at boiling points, even for condensation, we are talking at boiling points, the particles will have enough intermolecular forces in between them. And so they will start condensing and they will start to change from the state of being gas into being liquid. Finally, when we change from liquid to solid, this is called freezing. So liquid will be cooled and the particle will lose energy. As they lose energy, they will start to move slower. They keep moving slower and they cannot overcome the forces of attraction between the particles. So at melting points, the particles will have enough intermolecular forces in between them and they only start to vibrate. They cannot move freely as they were when they were liquids. Now, this is the freezing. They will start freezing and the liquid becomes solid again. So this is how to explain the changes in the physical state for the matter between the three states, solid, liquid, and gas, and use the particle theory and the forces of attraction between the particles to explain that. Finally, when we talk about state of matter, you will be asked in your exam to state the symbol for the state of matter in a chemical equation. So the state of matter, the state symbol is usually written to the right of the substance symbol between brackets. So you write the substance or the chemical and then right next to it you write the state symbol between brackets. So there are four states that you will be asked to put for your substance in chemical equations. The first one is the solid, and this is put as an S between brackets. The second one is the liquid, which is L between brackets. Third one is gas with a G between brackets, and then the aqueous, which is AQ between brackets. And aqueous here means the substance or the chemical is dissolved in aqueous solution or is dissolved in water. So when you do a reaction in water and your substance is soluble, then it becomes aqueous, and the state here is not solid, gas, or liquid, but it's going to be aqueous. So let's look at some examples. One of the examples is the reaction between chlorine gas and potassium iodide in a displacement reaction to give potassium chloride and iodine. So chlorine is used in this reaction as a gas, and potassium iodide is an ionic compound which is soluble in water. The reaction takes place in water, so this is the state here is aqueous. And as the reaction proceeds, we get potassium chloride, another ionic compound, which is also soluble in water, and this is aqueous, and then iodine is going to be solid. Another example is hydrogen chloride with calcium carbonate. In this reaction, hydrogen chloride, although hydrogen chloride itself is a gas, but we usually use hydrogen chloride as a gas dissolved in water, so it's going to be aqueous. So hydrogen chloride aqueous plus potassium carbonate, which is a solid. So you add potassium chlorate, add hydrogen chloride solution to potassium carbonate, which is a solid. That will give you calcium chloride, which is ionic compound, and it's will be soluble in water. So this is aqueous plus water. Water will always be a liquid. Water is not aqueous; it's liquid, and or if it's vapor, it's going to be gas. But water here is going to be liquid, and then carbon dioxide will always be a gas. So this is how to state the symbol of your state in a chemical equation.